Hi everyone, hope you're doing well. This is a video to go over the August 2018 Algebra 1 Regents exam. Please make sure that you post all these pages on Google Classroom for me so you get credits. And hopefully this one wasn't too bad. August is supposed to be the easier one. So let's see how you did. Let's get right to it. All right, zoom in a little bit. Here we go. Number one, the number of bacteria grown in the lab can be modeled by P of T equals 300 times 2 to the 4T, where T is the number of hours, which expression is equivalent to P of T. Okay, so this is one of the exponent questions. We've done these before. Remember, all these connected, the 2, the 4, and the T are connected by multiplication. So basically, because the associative property, you can kind of move things around. So you're going to move the 4, instead of a multiplication sign, you're going to make it a parentheses. You put the 4 with the 2, the base. And then you're going to simplify 2 to the 4th in the calculator, and you get 16 to the T, and that is the same exact thing. The only other thing you could probably do is put it in the calculator, and you want to go to y equals, and you'll put the original in, so 300 times 2 to the, I'm going to put this in parentheses, 4x, just so it knows that both of them are in the both of them are in the exponent, and then put your answer, 300 times 16 to the x. And then we're just going to go to the table, and then we should have the numbers that are exactly the same. And they are. See all those numbers exactly the same? That means they're the same exact answers. So that's the other way to do it. So I'll write here also, or can check in the table. Okay? All right, so number 2, during physical education class, Andrew recorded the exercise times in minutes and heart rates in beats per minute. 4 of his classmates. Which table best represents a linear model? All right, so we've done one of these the other day. I'm going to do now. So linear means a constant rate of change on the first try. So the answer was 1. If you add it up here, you'll see this from 0 to 1, you add 1, add 1, add 1, add 1. That's how you know you can do the trick. So 60 to 65 is plus 5, and then plus 5 again, plus 5 again, and plus 5 again. So it is constant on the first try. Remember the other things that I taught you that you can do? You can put this into the calculator. I'm just going to show you just for the answer. Stat 1, let's clear these out. So 0, 1, 2, 3, and 4. 60, 65, 70, 75, and 80. So the two things that I wrote down here, the first thing is the stat plot. So just make sure your stat plot is turned on, and then you could press zoom 9, and when you graph it, you should see that nice straight line. And then the other thing I wrote is talking about the correlation coefficient. So if you're checking for linear, okay, that you're checking for linear, and you go, oh, it's just going to finish up. All right, so go to Stat, move over to Calc, and we're going to go to LinReg, and we're going to check the correlation coefficient. You're going to notice that it's R. It's a perfect 1. When it's 1, that means it's a perfect fit, which means that's the answer. So that's just another way. There's this way, there's the graphing it way, and there's the checking the correlation coefficient way, and all of those will get you the same answer, which is number 1. All right, number 3. David correctly factored the expression m squared minus 12m minus 64. Which expression did he write? So this is just basically MAM's factoring. So you bring down the negative. Negative times a negative is a positive. And you want to know the factors of 64. Remember, I did teach you that trick that you could do. Y equals, okay, let's clear all this out. If you do 64, or in this case, negative 64, divided by x, and you go to the table, so second graph, any numbers introduced next to each other would be your factors. Anything that's a decimal, you just basically ignore. So that could help you get your factors, which are negative 16 and positive 4. Okay, number 4, the answer is 2. The solution to this, basically you're just going to do distribute. Just be careful, your negative times a negative. Solve, and you get x equals 2. All right, number 5, what is the value of f of negative 3? So again, this means, remember, inside the parentheses, that's going to be your x. So it's asking what is the y value when x is negative 3. So here's your x-axis. Go to negative 3, 1, 2, 3. And we're going to go up, and we hit the graph right here, and that is at 6. All right, number 6. If the function f of x equals x squared has the domain, remember domain of your x value, so 0, 1, 4, and 9, what is the range? So the easiest way to do this, and you had something like this on your midterm, is to put the formula x squared, or the equation, into y equals. You're going to go to your table, and then our x values were 0, 1, 4, 9, so I'm going to make a table 0, 1, 4, 9, and then I'm going to copy the corresponding y values, the range. So 0, 1, 4 would be 16, and then 9 would be 81. Okay, so this is probably the most easiest way to figure this out. As long as you know that range means y values. The other ways to plug in those numbers, 0, 1, 4, and 9, in and get the same exact values. But this one's just a lot quicker. So, all right, number 7, the expression 4x squared minus 25 is equivalent to. So this is DOPS factoring. You know this because you have a binomial, you have subtract, and you have squared. Those are perfect squares. So you take the square root of each side. Again, you're making your conjugates. Remember, 1's plus and 1 is minus. And your answer was choice 3. Number 8, compared to the graph of f of x equals x squared, the graph of g of x equals x minus 2 squared plus 3. So this is your transformation. You guys are really good at this. Remember, the inside's always opposite. So if it says you're going left or right, if it says plus, it's to the left, minus is to the right. So ours is minus, so it's going to be 2 to the right. And then the number on the outside, up or down, up is plus, down is minus, and that's going to be 3 up. So 2 units to the right and 3 units up. I'm going to write also can check on calc. Let's write graph and check on calc. Can graph and check on calc. So what you would do is you go to y equals, you'd put in your original, which I happen to already have in there, x squared, and then you put the new one, x minus 2 squared. Let's see, plus 3. And when you graph it, you should, let's get rid of all of this. So let's go to second y equals. We're going to turn off our stat plot. And we're going to go to zoom 6 so we can go into a normal graph. So there's your original. And you should be able to tell that it went to the right and up. So again, just by using this amazing graphing calculator, it can give us a lot of the answers. So it was right and up. All right, number 9, Lizzie has 30 coins that total $4.80. All of her coins are dimes and quarters. So dimes are D, quarters are Q. Which system of equations models a solution? So basically you have to know money plus money equals money, number plus number equals number, but you don't have to actually solve it. Okay, you just kind of come up with the equation. So this is the total amount of coin. So the dimes and the quarters equals 30. And then here's your money, money, money. So you have to know, and we've done these together, that dimes are worth 10 cents, quarters are worth 25 cents, and there's $4.80 in total. So that's how you come up with that. So number 9 is 2. All right, number 10. Gretchen has $50 that she can spend at the fair. Ride tickets cost $1.25 each, and game tickets cost $2 each. She wants to go on a minimum of 10 rides and play at least 12 games. So remember this vocab up here, okay? Minimum at least seems small, but actually greater than or equal to. Maximum at most seems big, but it's actually less than or equal to. So which system of inequality represents this situation when R is the number of ride tickets and G is the number of game tickets purchased? Okay. So the first inequality, each one has to do with the money. And this is the answer right here, because $1.25 was for the ride, and ride they said was R. 2G, right, because $2 for the game. And the most you can spend is $50. So you can spend equal to $50 or less than $50. So that's why it's less than or equal to. So far, actually, 2 and 3 would have been in the running, okay? But then it said that she wants a minimum of 10 rides. So minimum is greater than or equal to. So look to your R. Okay, well, they're both greater than or equal to. So now it's going to come down to the games. She wants to do at least 12 games, and at least is greater than or equal to. So that is the other symbol right there. So basically just knowing vocabulary tells you that the answer is 2. All right, number 11. 3 functions are shown below. So you have your graph, you have your equation, and you have your table. They tend to do this a lot where they give you things in different forms. So which statement is true? So the answer was 4. The y-intercept for g of x is greater than the y-intercept for both f of x and h of x. Okay, so let's look at the y-intercept. This is your exponential, so your y-intercept is 1. Here you basically just go to the table, and after you put the equation into y equals, you're going to put 3 to the x and then plus 2. And this right here, the plus 2, should tell you that it's 2 units up. Okay, so 2 units up from 0, 1. Okay, let me just write that a little bit better. From 0, 1. So 2 units up from 0, 1 should be 0, 3. But if you go to the table, you basically just look for where x is 0 and x is 0 at 3. So this y-intercept is 3. And this one is already done for us. It is -1. So g of x, which is 3, is bigger than 1 and bigger than -1. And that's why is choice 4. Okay, number 12. So this is a conversion one. We've done a bunch of these, so you guys should be okay with them. Remember, you can only simplify diagonally. Please keep that in mind. Olivia entered a baking contest. As part of the contest, she needs to demonstrate how to measure a gallon of milk. If she only has a teaspoon measure, she converts the measurements using the ratios below. So this is really nice when they already have it done for us. So which one is incorrectly written? So again, what you do is you just kind of start going across. So quarts and quarts, those can be canceled out. They're diagonally, so that one's okay. Pints has also something else that's diagonal. That's okay. Cups up. Is that diagonally down there? No, that's no good. Look, it's up there. You can't cross simplify. Okay, you can do it when it's diagonal, but not when it's across one another. So this is the one that's messed up. If it was flipped, it would be okay because cups and cups would be able to, cancel each other out. So that is your answer, number 3. 13, if y equals 3x cubed plus x squared minus 5 and z equals x squared minus 12, equivalent to, okay, so this is basically a polynomial question, but written with like the substitution. So you want to do 2y plus z. So y was a trinomial, z was the binomial. Okay, I just took away those inside parentheses. And then I basically combine my like terms. I combine my x squares, I combine my constants, and I got down to this trinomial. And then I distributed and I got my choice 1. All right, 14. An outdoor club conducted a survey of its members. The members were asked to state their preference between skiing and snowboarding. Each member had to pick one. Of the 60 males, 45 stated that they preferred snowboard. 22 of the 60 females preferred to ski. What's relative frequency? Again, that means fraction. That always means to make a fraction. And you could actually turn it into a decimal or percent as well. That male prefers to ski. All right, so the female really had nothing to do with the question. We want males that like to ski. So we know there were 60 males altogether, so that's going to be our denominator. But all they told us that was 45 out of those 60 wanted to snowboard. That means the other portion wanted to ski. So just do 60 minus 45 to get 15. 15 over 60 reduces to 0.25. So number 14 is 2. Number 15, when the function g of x equals, what you have right here is a piecewise, is graphed correctly, how should the points be drawn? Okay, so they're saying open circles at both 3. So both 3's, nope, they're not both open. Closed circles, well, we know they can't both be closed because then it won't be a function. Open circle at 315 and a closed circle at 313. Okay, so here 5 times 3 would be 15. So 15 would satisfy this one. So that should be closed. So that's actually no good. And here, 3 squared is 9, 9 plus 4 is 13, so this one would satisfy this one. This should be open, so that should actually be reversed, so it is choice number 4. All right, 16. Actually, you could probably even graph that on the graphing calculator to check it as well. 16, if f of x equals 2x squared plus x minus 3, which equation can be used to determine the zeros of the function? So whenever they say zeros, basically what they want you to do is in place of f of x, put a 0, and then you're just going to solve it. Okay, so this one we're going to do tricky try. So 2x and 2x, and then multiply 2 times negative 6. Remember, it's just mams, M-A-M-S. Drop down the first line. A positive times a negative is a negative. So what multiplies a negative 6 and adds 2? There's an imaginary 1. It's 3 and negative 2. Always simplify your tricky try, and then you come up with this answer. Okay, this one, you can also check on calc, put into y equals, and compare tables. Okay, this should also work. So if you didn't actually want to solve all of it, you could actually have done this. So let's put that in. So 2x squared plus x minus 3, and then we'll put the answer in. So we have 2x plus 3, and then we have our x minus 1. Okay, and we're going to go to our table. And just like the other question I showed you previously, see how the tables match? That's how you know they're the same exact thing. So that's what we're doing on number 16. All right, 17. So again, 16 was choice 2. Number 17. Each day a local dog shelter, yay dog, spends an average of $2.40 on food per dog. The manager estimates the shelter's daily expenses, assuming that there is at least one dog in the shelter, using the function e of x equals 30 plus 2.4x. Okay, so in the beginning, they talked about $2.40 on food per dog, so that automatically makes the x the dog. So this right here has to do with the food, and this amount is just like the extra expenses they have to pay for, maybe like, could be toys or medicine or, things like that, anything else besides food. So which statement regarding the function e of x are correct? X represents the number of dogs. Yes, we just talked about that. 240 per dog, so x is dog. Okay. X represents the number of volunteers. Nope, we just said it had to do with dogs. $30 or 30 represents the shelter's total expenses per day. Total expenses would be this whole entire thing out here would be total. That's part of it, but that's not the whole entire thing. 30 represents the shelter's non-food expenses. Yes, so this is the food, this is all the other stuff. So it is 1 and 4, so choice 2. 17 is choice 2. Okay, number 18. Which point is not in the solution set of the equation? All right, so what we're looking at was actually looking at a quadratic equation. So there's two different ways you can do this. So the answer is choice one. That's the one that's not correct. Basically, it's just simply just plugging in and checking. You're putting in x is -2, y is 10, and you're simplifying it and showing the two sides are not equal. So that's one way to do it. The other way is you want to get this into y equals ax squared plus bx plus c form. And then what that allows you to do is allows you to go to the calculator. Okay, so let's clear all this out. And then y equals, so we have 1/3 x squared, we have minus 5/3 x, and then we have plus 5. So then all you just do is go to the table and we look and see what was our first one, -2. So -2, they have as 9.6 repeating, and we have 10. So that's no good. So this is the one that is not there, but then everything else should be there. So what else was it? It was -1/7, that's correct. It was 2/3, that is there, and then it was 5/5, which is there. So the first one, choice one, is the one that is not there. 19, the functions f of x and g of x are graphed below. Based on the graph, the solution to the equation f of x equals g of x are. All right, so basically you're looking for the intersection points. And when you tell me intersection points, you always want to tell me the x values. So it is choice 3, the x values of the points of intersection. That's basically, you know, just basic vocabulary for what solutions of graphs even mean. All right, number 20, sequence. Okay, for the sequence, -27, -12, 318, the expression that defines the nth term, where a sub 1 equals -27 is what? All right, so we look at it, and this is arithmetic. Okay, these numbers keep increasing by 15. That's our common difference. So we have our a sub 1 was given, that's -27. We have our common difference of 15, and basically I just plugged into the explicit formula. So a sub 1 is -27, the common difference is 15. And actually you didn't really have to go any further. That was that unsimplified answer right there. Okay, and so the answer is choice 4. Just remind you, geometric is exponential, where arithmetic is your linear graph, and this is your exponential, is the times instead of the multiply, and it's r to the n-1. All right, hopefully that page wasn't too bad. Remember, as we get closer and closer to 24, it's going to get more difficult. All right, so 21. The data obtained from a random sample of track athletes show as the foot size and the athlete decreased, the average running speed decreased. So as the foot size got smaller, the average speed got smaller. So which statement best supports the data? So they're talking about causal or causation and correlation. Remember, correlation does not mean causation. You can't prove 100% that one thing is making something happen. So you can't prove that just because the foot size is smaller, then the speed smaller. You could have someone that has a bigger foot size and the speed is small. So this is definitely not a causing something, you know, one causing the other. It just has a relationship. So that means correlation. So the sample of the track athlete shows a correlation. Okay, you're not picking anything that says causal, only a correlation. Okay, something, again, this is the one I always use, is that you have a blizzard, 6 feet of snow, that causes you to have no school. That's the only time you could really 100% prove something. This, they have a relation, but it doesn't mean one thing is causing the other. So a lot of things in our honor Regents will always be correlation and not causation. So just keep that in mind. All right, 22. This has come up a lot for us. Which system of equations will yield the same solution as the system below? So again, you can solve all of these. All right, that can solve to check, but I like doing the shortcut. Remember, we're going to see what we're multiplying by, and that's something called the scale factor. So the answer was choice 3. I'll just go through, I guess, these ones, why they don't work. So this first one right here was multiplied by -2, and -y times -2 should be positive 2y, so that's no good. This one, this was the mistake right here, was being multiplied by -2, and 3 times -2 is -6, so that's no good. This worked perfectly. This whole top one, all of those were multiplied by 2, so 2x minus 2y equals 6. The bottom by 1, so it stays the same, so that was the winner. And for this one here, 22, the one that was wrong was here, was being multiplied by 3. And so -1 times 3 should be -3 and not +3. So that one wasn't too bad. They didn't make it too tricky. All right, 23. Which of the 3 situations given below was best modeled by exponential? So exponential, you're looking for exponents, percents, double, triple, something like that. So here we go. Doubles. That's automatically is exponential. Okay, a plant grows by 1 inch every day. That's something constant, every day, constantly, the same exact thing. That's going to be your linear. Here I see a percent, so I know that's definitely exponential. That's exponential growth, exponents, so it's going to be 1 and 3. So that's that. Okay, number 24. The length, width, and height of a rectangular box are represented by 2x, 3x plus 1, and 5x minus 6, respectively. So that just kind of means in order, like length goes with 2x, your width goes with 3x plus 1, and your height 5x minus 6. When the volume is expressed as a polynomial in standard form, what's the coefficient of the second term? Okay, so you have to know that your formula is length times width times height. So we just plug in length is 2x, width is 3x plus 1, and your height is 5x minus 6. Now, both of these are binomial, so you know, I've said this 100 times, that has to be in parentheses, okay? So basically, you want to just multiply those two by double distribution, combine your like terms, get down to this trinomial. Then you distribute your 2x to each term. And then you want to make sure that all your like terms are combined and it's in descending power order, right? That's what standard form means. And then after you've done that, when it's in descending power order, this second term right here, that's what they want to know the coefficient. The coefficient is the number in front, and negative 26 is your answer. Okay, on to our part 2s. Number 25, explain how to determine the zeros of f of x. Actually, we just did a question like this on part 1. Remember, zeros means the f of x is going to be 0, okay? So explain means word. So replace f of x with 0. You can kind of see that's what I did here. Then we're going to take each one of these factors and set those equal to 0, and then you're going to solve each one to get the answer. So basically, you took what you did right here, because you had to solve it anyway, and then you just, did it with words. So I wound up getting negative 3, 1, and 8, and then I explained it another way. I plugged f of x into y equals, and then I graphed to find the x-intercept, so you could do that. Okay, might as well just show you this. So y equals, we have x plus 3, we have x minus 1, and then x minus 8. So if we go to graph it, our 0 should be negative 3, 1, and 8. And then another way you can actually do it is to go to the table. So kind of do the same thing, start with y equals, go to the table, and you're looking for where y is 0. And that's going to happen at 3 places. It's going to happen at negative 3. It's going to happen at 1, and then it's going to happen at 8. So the Regents actually, there you go. Regents actually almost have any one of these because it does not say algebraically. So a table is okay. But again, your 3 answers were negative 3, 1, and 8. Just to make sure anytime it says zeros, that's where the f of x is going to be 0. All right. 26. 4 relations are shown below. State which relations are functions. So, they love to always ask these kind of questions, okay? So remember, x values cannot repeat, y can. It must pass the vertical line test. Those are all the things that make a function. So for the first one, this one fails the vertical line test. You have 2 filled in dots right there. So that's going to fail the vertical line test. That is no good. Number 2, which is down here, your x's of 2 and 1 repeat. That's no good. Number 3 is good. None of the x values repeat. Number 4 is good. It passes the vertical line test. So which one are the functions that were your 3 and your 4? And tell me why the other ones were no good. So I wrote in relation 1 and 2, each element of the domain does not correspond to one and only one element of the range. So that's our fancy little sentence, okay? It's not really too much of a little sentence, a big sentence, but. And then I wrote specifically in relation 1, the x value of 6 is repeated, right? That's what's showing right there. And then in relation 2, which is right here, the 1s and 2 are repeated. So that's what's making it no good. All right, 27. The table below represents the height of a bird above the ground during flight, with P of t representing the height in feet and t representing time in seconds. And then we want to do average rate of change. Remember, this is essentially slope, but it's just a different formula. It's f of x2 minus f of x1 over x2 minus x1. This is x1, this is x2. So we're going to do f of 9 minus f of 3 over 9 minus 3. So f of 9. Okay, so when x is 9, what's the corresponding y value? 3.41. When x is 3, what's the corresponding y value? 6.26. And then you simplify and you get negative 0.475 feet per second. All right, moving on to number 28. Is the solution to the quadratic equation written below rational or irrational? Justify your answer. So this is actually them asking you to do the discriminant, okay? So this is asking about the nature of the roots. What kind of roots are these? So I had taught you when you plugged in and you got a number that was positive, it meant it was 2 real roots. But then you had to decide if it was rational or irrational. It had all to do with the specific number and if it was a perfect square or not. So 89 is not a perfect square. That means it would be irrational. Okay, because that would mean if you had it in the quadratic formula and you put the square root over it, you took the square root of it, you get a non-terminating, non-repeating decimal. So here, the solutions are irrational because when I figured out the discriminant, I get a non-perfect square. So this is what you had at. So this is actually a pretty good question. We haven't really seen one like that before. All right, 29, here's our literal equation. The formula for converting degrees Fahrenheit to degrees Kelvin is as follows. We want to solve for F. So I showed it 2 different ways. I'll kind of just go over the top one. I think it's a little bit quicker. And plus, I always tell you whenever you see a fraction, I want you to get rid of that first by multiplying by the reciprocal. So multiply both sides by 9/5. It gets rid of your fractions. 9/5 K equals F plus 459.67. Subtract that, and just like that, in 1-2 steps, you have the F completely by itself. So this is just another way that I have in there by distributing, but this way I believe is just so much easier. So hopefully you chose that way to get rid of that fraction first. All right, next page. Number 30. Solve the following equation by completing the square. So this is the only way this could be solved. It had to be done completing the square. Remember, in order to do that, it has to be equal to a constant, which it already is. The a term in front here has to be 1. So let me write. So you remember y equals ax squared plus bx plus c. So you know what I'm talking about. Okay, that's a bx, so plus bx. So a must be 1, which it is, and it must have a linear term. It must have the middle term, which it is. Okay, very good. So it has that. So we can do this. So basically, you're just going to add b over 2 squared to both sides. 4 divided by 2 is 2. 2 squared is 4. Then here, the shortcut is you just take the half of the b term. Half of 4 is 2, and you square that. This side I just basically combine, and I took the square root of both sides. 6 is a non-perfect square, so you can't take the square root of it, so you just leave it. You can't simplify it. And don't forget that plus or minus. That is the most important thing that a lot of people forget. Don't forget the plus or minus. And then you should get -2 plus or minus radical 6. And you can write it together or separate, but x equals -2 plus or minus radical 6 is your answer. All right, 31. The students in Mrs. Langford's 4th and 6th period algebra classes took the same test. The results of the scores are shown in the following table. So this is pretty like intense table. They had a lot going on here. So this x bar is average. That's your standard deviation, your population standard deviation. N is the number of, terms or numbers or elements. You have your minimum, which is your lower extreme. Your quartile 1, which is also called your lower quartile. Your median, which is your second quartile. Your upper quartile, which is your quartile 3. And then the max, which is your upper extreme. So it had a lot going on. So it says, based on the data, which class has the largest spread? Remember, spread is variability. And you've done these kind of questions before. So explain how you arrived at your answer. So I want to just point to this first. It says for spread, you can only look at the range, interquartile range, or the standard deviation. So only one of those 3 things will help you out. And I kind of showed it by the stars. So here's my standard deviation. 4th is larger than 6. Okay. Then over here, I figured out the range for each one. I just took the max and the min. So 96 minus 58 got me 38. 96 minus 59 got me 37. So here again, 4th is the winner. And then the interquartile range is the Q3 minus Q1. So 87.5 minus 69 is 18.5. And then 88 minus 71.5 is 16.5. So in all of those, no matter which one you used, 4th period was the winner. So 4th period, because I wrote all 3, but you just pick one of them. Range, interquartile range, or standard deviation is greater, meaning their scores were more spread out. More spread out, aka variability. So, all right, next one. 32. Write the first 5 terms of the recursive sequence. Remember, it's going to be recursive because you have the n-1. It just means you're using the number before it. Okay, so I literally just copy this, and then for the second term, wherever I see an n, I'm going to put a 2. So I'm going to work on that subscript first. So 2 minus 1 is 1, and here's where the recursion. I'm figuring out the second, but I'm using the first. So a sub 1 is 0, and then I just follow order of operations. So 0 squared is 0, then 2 times 0, and then minus 1 is -1. Okay, for 3, wherever I see an n, I put a 3. So 3 minus 1 is 2, so I'm going to use the a sub 2 value, which is -1. Make sure you're using parentheses when you put this in the calculator. Be very careful. Okay, 2 times 1 is 2, minus 1 is 1. Okay, next 2. Here I put in a 4. 4 minus 1 is 3. A sub 3 was 1, so that's how that becomes a 1. Exponents, multiply, subtract, and you get another 1. That's interesting. I've never really seen one where there was the same exact numbers. Okay. And then number 5, you plug in a 5, which gets you a sub 4. And then a sub 4 is 1. And then squared, multiply, and we have another 1. So it's -1, and then 1, 1, and 1. Oh, that's interesting. All right, number 33. We're already up to our part 3s. Sarah wants to buy a snowboard that has a total cost of $580, including tax. She has already saved $135 for it. At the end of each week, she is paid $96 for babysitting and is going to save 3/4 of that for the snowboard. So that's what makes this question so tough. Write an inequality that can be used to determine the minimum. Remember, minimum is going to be greater than or equal to of weeks Sarah needs to babysit to have enough money to purchase a snowboard. All right, so legend, let x equal the number of weeks. So the 135 is the amount that she already has. So now here's, again, what makes it so tricky. Usually you would just look at the 96 and do 96x is 96 per week, but she didn't actually make 96. Or she didn't actually save all 96. She only saved 3/4 of it. So 96 times 3/4 is 72. So that's how much she's saving. So this should be 72, not 96. So be careful. Okay. Determine and state the minimum number of full weeks Sarah needs to babysit. So basically you just have you solving it. And like always, they're never going to give you something that comes out to be a perfect whole number. They're always going to give you the decimal because they want you to round. Now don't round here. You technically are rounding in your answer. So what's a number of full weeks that's bigger or equal to 6.1? Well, obviously it is 7. And then I just showed the work down here where I put, or the check, where I put in 7 weeks and it was enough, and then 6 weeks was not enough, just to prove it. So just be careful with this one. It is 72, not 96, and then make sure you are rounding here. All right, number 34. A car was purchased for $25,000. Research shows that the car has an average yearly depreciation rate of 18.5%. Okay, so this is our initial amount. This depreciation means subtraction. Rate is your percents. So we have everything that we need to do our exponential decay question. So this is the formula that we're used to using, but they did make it a little more difficult on us, and they switched up some of the letters. So V of t and t. So for the first one, I used V of t, and the second one, I used the formula that we're used to using. So V of t equals 25,000. That was our initial. 1 minus 18.5% t. So notice over here I did do a key. A is V of t. And n is t. I then converted the decimal, subtracted the numbers here. You notice your base is less than 1, which makes sense because it's depreciation. You couldn't go any further because you didn't know what t was. Now over here, I use the formula that you guys are used to using. So you do have to have a key for this one, okay? It's so important. When they want you to use V of t and you don't, you have to have that key, okay? So V of t equals A, and then T equals N. It's essentially the same thing over here. 25,000 at the beginning, 18.5% is 0.185, and your base comes out to be 0.815. The only difference is that of V of T, it's A, and instead of T, it is N. But again, if you're going to use this one, you have to use a key. You have to have it. It's so important. All right, next part. So it says determine to the nearest cent how much the car will depreciate from year 3 to 4. So we want to know the difference. We got to figure out the price for year 3, the price for year 4, and then we have to figure out the difference. Okay, so basically just going to use the formula from above, the equation from above, and I'm going to use this one since they wanted us to do V of t anyway. And I'm going to do year 3 minus year 4. So I just plug in here. 3 is your t, and here 4 is your t. So put in the calculator, press enter, write down everything you see. Okay, then the difference is subtracted. So I just subtracted those, and I get 2,503.71311. And I know nearest hundredth, it's $2,503.71 because money is always nearest hundredth. And that's how much the car will depreciate from year 3 to year 4. Now, notice I only wrote in the nearest cent here. I didn't round here because usually you're not really supposed to round to the end. I don't think the Regents would mark it wrong if you round it here, but I always tell you guys to always round at the end because it can definitely, affect your final answer at all. But again, we plugged into the equations. We got this number here for 3, this for 4, subtracted them, and then our difference was the depreciation to the nearest hundredth. All right, number 35. Graph the following system of inequalities on the set of axes below. Okay, so basically they gave us 2 inequalities, and neither one of them were in slope-intercept form. So the first one, you divide everything by 2, and you get y is greater than or equal to 3/2 x minus 8. So your slope is 3/2, your y-intercept is 8. excuse me, negative 8. So we start at negative 8, and we're going to go up 3, right 2, up 3, right 2, and follow that pattern. It's greater than or equal to, so it's a solid line. And then I'm going to shade above, so I go to my y-intercept, and I shade above. And I know it's kind of hard to see, but I do have the original inequality inside the shaded region right there. Okay, for the second one, you subtract 2x from both sides, and that gives us y is greater than negative 2x minus 5. So my slope is negative 2 over 1, and my y-intercept is negative 5. So I'm going to go to negative 5. I'm going to go down to right 1, down to right 1. Careful, this one is dotted, okay? Greater than does mean dotted, so make sure I can see that it's dotted. Here's my negative 5, and I also want to shade above. And again, it's hard to see, but that's the original form inside the shaded region. And don't forget your 1 box equals 1 unit. And I did that right here, by the way. Inequalities must be in original form, and they must be inside the shaded region. I did write my S where my solution set was. Okay, so then they actually gave us 2 specific points, and they wanted to know if they were solutions or not. So based upon your graph, explain why 6, 1 is a solution to the system and why negative 6, 7 is not a solution. So this is what I have. 6, 1 is a solution to the system because even though it may not look like the point is in the intersection of the shaded region. So 6, 1 is right here. It's right on the actual line. So it might be hard to tell that it's really inside because it's on the line. So it's on a solid line, which means it's equal, which means it is a solution to the set. That point would satisfy both inequalities, okay? So this 100% is a solution because it's on the equal or on the solid line, which means equal, and it would satisfy both inequalities. Now the other point, which is negative 6, 7, which is this point right here, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7. If you notice, that's on a dotted line. That's no good, okay? Negative 6, 7 is not a solution to the system because it's on a dotted line, which means it's not equal to, okay? Points on that dotted line are not in the solution set and would not satisfy both inequalities. So you have one good and one not good. And then over here in this blank space that I had, what I did is I just showed you by plugging in 6, 1, when you plug it into both inequalities, it does, both of them come out to be true, so it satisfies both. And here, negative 6, 7, when you plug it in, it only satisfies one and not the other. So this cannot be a solution point, okay? So 6, 1 was a solution point, and negative 6, 7 was not a solution point. 36. Paul plans to have a rectangular garden adjacent, that means next to, his garage. He will use 36 feet of fence to enclose 3 sides of the garden. The area of the garden in square feet can be modeled by f of w equals w, and then 36 minus 2w in parentheses, where w is the width. Okay, so set of axes, sketch the graph. Okay, so you could put it right into the calculator looking like this. That's not a problem at all. You can distribute and get 36w minus 2w squared. It doesn't matter which way you do it. You want to go to y equals. Okay, and you're just going to plug this in. I guess I'll plug it in this way. Negative 2x squared. And then plus 36x, and you go to the table, and this is where all these numbers, how I got them. So 0, 34, 64, 90, 112, 130, 144, 154. So you want to keep going until you get your vertex, right? You always must have vertex in your table, and you always want to go until you can't plot anymore. So here we can go up to 20. So the highest number I could plot was 18. So your table should go from 0 to 18. All right, so basically I just plotted all those points. Okay, don't forget to write the original form of the equation on the line. Okay, make sure these are labeled. F of w, which is your area, w is your width, and then I wrote width versus area up there. Or you can write, well, it's not really a scatter plot. So let's actually write Paul's rectangular garden. Let's write that. That's probably better. Paul's rectangular garden. Okay, so down here it asks us to explain the meaning of the vertex. So our vertex was this point up here, 9 and 162. So let's remember what this stood for. X or W was our width, so that means 9 was our width, okay, and it's feet, so 9 feet is the width. 162, that's our Y, that was the area, so 162 square feet. So basically, that's all I wrote. So this is my vertex, 9 and 162, width and area. So notice it does say context. You can't just say it's the highest point on the parabola. You have to actually tell me what it stands for, so the width and the area. So when the garden's width is 9 feet, its area is 162 feet squared, or anything like that. Just as long as you're saying the width is 9 feet and the area is 162 feet squared, then you're going to get it right. So again, context, you need to have width and area to get this question right. So that wasn't too bad. The graphing wasn't too bad. This wasn't too bad, again, just as long as you use width and area. All right, this, in my opinion, was the toughest question on the whole entire Regents. And of course, it makes sense because it's 37, the toughest one. But I promise you, you did do this with me. I did teach you a tough age question, okay? So I want to remind you, present means now, future means you add, past means you subtract. When you see will and was, that's your equal sign, right? Usually it's the word is, but in these kind of questions, it's will or was. And if there is a double will or was or will, the first one is the equal sign, okay? So remember all of that. That's what I had taught you just to do this question. Okay, here we go. Oh boy. At the present time, so that's our time now, Mrs. B's age is 6 years more than 4 times her son's age. 3 years ago, she was 7 times as old as her son was then. If B represents Mrs. B's age now and S represents her son's age now, write a system of equations that could be used to model the scenario. Okay, don't freak out. Just go little by little, okay? Let's start with the top of the legend. B is Mrs. B now. So B is Mrs. B now. And then S is her son's age now. So that's not bad. Okay. This is all talking about a present time, which is okay, good. We have our present information, but it's also talking about a past age. So we need to figure out our past age. So past means to subtract. So you can take the B from here and subtract 3, and the S from here and subtract 3. Again, you've done this. I know you've done this. We did this like in October with our word problems. So this is Mrs. B's age 3 years ago, and then Mrs. B's son's age 3 years ago. All right, so that's just the legend. So now we're going to use that and use these words up here to come up with an equation. Okay, so at present time, so that means only focus on the top, the B for Mrs. B and the S for her son. So Mrs. B's age, okay, so that's going to be B. Is our equal sign. 6 years more than means plus 4 times her son's age, 4S. Okay, that wasn't bad. Now, 3 years ago, so ignore the top, now focus on the bottom. We're going to use these. She was, now notice there's a double was, right? Was, and I said always use the first one as the equal sign. So she meaning Mrs. B, so B minus 3. Was is my equal sign. 7 times, her son, S minus 3. Okay, so hopefully you kind of remember how to do that. I promise you we've done it, and that's all you have to do. Okay, so now that we have our equations, now we're going to use this system to determine algebraically, so no table, the ages of both Mrs. B and her son now. So we're trying to solve for the B and also solve for the S. So this is basically set up for substitution. They want you to take, they want us to take these two equations, and then in place of the B, put 4S plus 6. So in place of the B, I'm going to put 4S plus 6. I'm going to carry down my minus 3. Carry down the rest, and I'm just going to simplify, and I get 8, okay? I think I also showed it another way. I think I showed it where you could actually, what did I do? I guess I solved for B on the bottom, on the second one, and then put that in place of this B over here and equal to 4S plus 6. So really whatever you want, but either way you get S equals 8. So once you figure out 8, then don't forget to plug back in because you have to figure out Mrs. B. So right now S would be the son, so the son is 8. When you plug back in, you figure out that Mrs. B is 38. And this is how old they are now, okay? This is how old they are now. All right, one more part. Oh, this is tough. Determine how many years from now. So now we're trying to figure out how many years from now. So we're talking about future. Okay, so this would be future. Determine how many years from now Mrs. B will be 3 times as old as her son Will. Look, there's that double will again, right? If it's double will or was, the first one is equal. Okay, so for years, X equals number of years from now. And I promise you, we also did this on the tough age day as well. Okay, so since it's future, right? So future equals add, I'll write add X since we really don't know. And again, past is subtract. Now we're on future. So we're going to add. So 38 plus X equals Mrs. B's age X years from now. And then 8 plus X equals Mrs. B's son's age from now. So we took what their ages were and we added on X to figure out how much they would be. So then basically here we go. We're going to use it. So Mrs. B, so that's going to be your 38 plus x. Your will is your equal sign. 3 times, so 3 times. Our son, x plus 8 will be then, so you're using your future ages. You solve and you get x equals 7. And that's the number of years. So in 7 years, Mrs. B will be 3 times as old as her son will be then. The other thing that they allow, because see how this one said algebraically, but this one did it, they did allow you to do a table. And some people just started with their age and then just kept adding. Okay, they kept adding each year. This goes up by 1. This also goes up by 1. And then in 7 years, 1, 2, 3, 4, 5, 6, 7. That's when this one was 3 times as old. So it really is up to you how you want to do this last part, but it should be 7. So whew, that was a really, really tough one. Hopefully you guys understood, or at least remembered a little bit from what we did in class. So wow, definitely the toughest one in the whole entire Regents, but hopefully you did okay. Okay, please, as always, if you have any questions at all, please reach out to me. Also, make sure you post this on Google Classroom so you get credit for it. And hopefully you did okay on this one. It wasn't August, so it's supposed to be a little bit easier. But if you have any questions, I'm always here for you. All right? Have a great day. Bye.